Good afternoon and a very warm welcome to all for the OCPP Technical Session. This session is in collaboration with Open Charge Alliance as part of India Smart Utility Week 2025. It is my great honor to invite chair for this session, Mr. Ravi Seethapathy. He is an advisor at India Smart Grid Forum. Welcome, sir. I would like to invite moderator for this session, Mr. Suresh Babu. He is a scientist at Department of Science and Technology. Welcome, sir. Now may I invite theme presenters for this session, Ms. Lonneke Driessen, Director at Open Charge Alliance. Welcome, ma'am. May I invite Mr. Anand Kumar Singh. He is a General Manager at India Smart Grid Forum. Welcome, sir. Now I would like to invite panelists for this session, starting with Mr. Pradeep Aggarwal. He is a General Manager at BRPL. Welcome, sir. May I invite Mr. Manoj Kumar Upadhyay, Deputy Advisor at NITI Aayog. He will join virtually later. May I invite Mr. Singh. He is a Smart Grid COE Manager at ESKOM, South Africa. Welcome, sir. May I invite Akshay Mukesh. He is a DGM at Ather Energy. Welcome, sir. May I invite Mr. Bidyut Mazumdar. He is a Chief Manager at Siemens. Welcome, sir. I would like to invite Mr. Jai Prakash Singh. He is a Project Manager at ECOG, Germany. Welcome, sir. I am handing over the session to take moderator to take the forward this session. Thank you, sir.
Thank you very much, Mr. Bala, for the introduction. Without taking much time, may I request the chairperson, Dr. Ravi Seethapathy, sir, to give his opening remarks before we go for presentations. Thank you, sir.
Thank you, Mr. Babu. Friends and colleagues, at least in my view and a few remarks that I will make, is an important session. Simply because if you look at the momentum of where e-mobility is headed, I would be not hesitant to guess that it is moving toward the east. So it is our opportunity to lose if we have differences within the various nitty-gritty like we had with smart meters. Smart meter, we fought for 14, 15 years and we haven't settled the score. I hope it really does not occur here. It appears it hasn't so far, which is a credit to you all, that this is going well, very well, so that we can have an integrated system and we can do so many good things with it. So with that, what I'm going to do is I'm going to turn it over to Mr. Suresh Babu, and he will moderate this session, and then in the end, we will wrap it up. After he wraps up, I have some closing remarks as well. So over to you, sir.
Thank you very much, sir, for setting the tone. And as we all know that India, spurred by so many good initiatives by the government, we are marching towards achieving the goals. And OCPP, that's this standard is very much important for our country, because back-end integration is crucial both for two-wheeler and three-wheeler and also for heavy-duty vehicles. Indeed, today we are going to have 3 presentations and also one more presentation online, 4 presentations altogether. And Miss Lonneke Driessen, Director Open Charge Alliance, will be presenting about OCPP. Madam, can you please take over?
Yes, thank you. Welcome. Thank you for attending this OCPP Technical Session. My name is Lonneke Driessen and I'm the Director of the Open Charge Alliance. And I've prepared an update for you, so what has been happening with the Open Charge Alliance and what has been happening with OCPP. I gave a presentation earlier this morning, so maybe some of you have already seen a couple of slides, but for completeness, I've included them in this presentation as well. So if you have missed the presentation this morning, you still are fully up to speed after this afternoon. 1 second, not sure if I'm pointing in the right direction. Maybe I can just say next slide. Also works. So first of all, an update on the Open Charge Alliance as an industry association. So as you know, we are an industry organization, so we are not a formal standardization organization such as IEEE or IEC, but we have participants who join, and at the moment as it stands we have 408 participants, and we are very proud to have 6 participants from India, Indian companies who contribute to the Open Charge Alliance, the development of OCPP. And in this graph, oh, sorry, I was going to, did I do that? Yeah, thank you, it worked, thank you. In this graph you see all the different countries where participants originate, and you see that by far most of our participants come from Korea. Korea, as you know, is very active in the automotive sector, but also in electrification. So there's a lot of things happening in Korea, and that's why there's so many companies from Korea joining. But you see also a lot of companies from the United States, Germany, and the Netherlands, and also from China. But it's important to note that China does not use OCPP, so the Chinese participants are joining for export reasons, not for the domestic Chinese market. If you look at the split between continents, there's sort of a 50-50 split between Asian members and European members. But OCPP is an open source protocol in the sense you can just download it and use it the way you like. So you don't have to be a participant of OCA to benefit from OCPP. And here in this graph you see the number of downloads in the past year and to which country, and the letter print is too small for you to read. What you can take from the bottom slide is that there are 130 countries where OCPP is being downloaded to. So that shows us that in 130 countries, people are considering EV charging, EV chargers. They're downloading OCPP, they are reading it. Not sure if they're actually using it, but at least they know that it exists. And that is great because, of course, the whole electrification is a global movement. It's not just about the US or Korea. We all want to move forward with this new transportation technology. Oh. So if you look at, even though we do not have that much participants from India, you see that there is a huge number of downloads coming from India. And of course it makes sense because, as you know, India has a huge IT sector, and a lot of companies from all around the world outsource their IT development to India. So that is one reason that explains the huge number of downloads in India. And I think it's great for India to consider that you already have a big export product, which is your IT sector. You could also maybe consider actually exporting hardware, so developing charging stations using OCPP. And sorry, my slide keeps moving forward. So, but it's something that India could also consider, not just export your IT services, but also export actual charging stations, charging infrastructure. What you can see from this picture is that OCPP, I mentioned, is developed by OCA, but it has been published as an ISC standard as well. And the ISC number is a little bit difficult to remember. It's 63584. And to this end, if you look in front of you, we have a sticker where the number is written down. So if you ever forget what's the IC number for OCPP, well, you can read it, 63584. I know it by heart, but I think it's not an easy number to remember. You can, of course, still download it from the OCA website for free. You can also choose to purchase it from the IEC portal. It's exactly the same, so there is not a single letter that has changed. So you can decide which version you want to get. What was important in the voting process is to agree with IEC the contribution of IEC experts. Of course, if you're an OCA participant, you can contribute to OCPP. If you're an IEC expert, you can also contribute. And there are, if you are not an OCA member but you are active inside IEC, there are 3 options for you to consider. So first of all, of course, your company can always join OCA. That means that you have to pay the participants fee, but it means that you and all your colleagues can join OCA work, and you can vote. But the second option is for IEC experts, so you can join as a liaison for free. And then you can join all the groups as well. So that's your second option. And lastly, if you're too busy with all different work and you don't have time to join the OCA meetings, you can always, from within your technical committee or systems committee, see access to all the draft documentation and provide feedback in that way. So as an IEC expert, you have multiple options to choose from should you want to contribute or influence the direction of OCPP. So this is an overview of all the different versions. OCPP has been developing together with the industry. So what we did is we made the first version, we published it, the industry started using it, gave feedback on bugs or improvements that needed to be made, but also gave feedback on functionality that was missing. And the most prominent version out in the field today is the OCPP 1.6 version. It stems from 2015, so it's already 10 years old. So it includes all the things we knew we needed back in 2015. And if you are running a charging network in a sort of a basic way, so you need authorization, you need transaction management, you need, for instance, smart charging or reservations, security, of course, that's all included in OCPP 1.6. So that is all that you're using. If that is all that you're using today, then OCPP 1.6 is a great version to use. And the Open Charge Alliance is still supporting this, of course, with testing tools and the certification program and PlugFest. So you can still very comfortably keep using OCPP 1.6. But as I said, it was published 10 years ago, so all the things we've learned since then, we included in newer versions of OCPP. 2020, we published OCPP 2.0.1, and that's actually the version that has been published as an IEC standard, and that includes, on top of everything that 1.6 offers, additional support for better device management, for error handling, for user interface, and for ISO 15118-2, which is a standard towards the electric vehicle. You can see by the colors that at least that's what I try to express with colors, OCPP 2.0.1 is not backwards compatible with OCPP 1.6, and that has been a barrier for the industry to move easily from the 1.6 version to the 2.0.1 version, and we've learned from that. So as of that point, all the future versions of OCPP will be backwards compatible. So this January, we released yet another update of OCPP 2.1, and 2.1 is backwards compatible with 2.0.1. So the migration from 2.0.1 to 2.1 is very easy, as opposed to from 1.6 to 2.0.1. What we've added in OCPP 2.1 is bidirectional charging, the support for distributed energy resource controls. If you're a utility company, there is some information you need to convey to distributed energy resources, solar farms, wind farms, and electric vehicles are no different. At large scale, they can provide a massive amount of energy feeding back into the grid. And then, of course, as a utility, you want to make sure that it doesn't, that it adheres to all the requirements regarding frequency stability and voltage stability and such. So all the messages we've included in OCPP 2.1. Payment terminals, QR code, dynamic QR code support for alternative ways of paying, we've included that. More elaborate smart charging, and particularly for Korean and Indian and Taiwanese use cases, we've included battery swapping, which is not that different, but it's a little bit different. A transaction in battery swapping is a little bit different than plugging in your charger. So we've included that as well. And lastly, the alignment with the updated version for ISO 15118, the -20. So it depends on what use cases you want to execute, whether you are perfectly fine with 1.6 or at some point you decide to bite the bullet and migrate to 2.0.1 and 2.1 and onwards. So it's up to you. As I mentioned, the 2.1 version is the latest version, and there's a long list of new functionality, but also, which is a little bit harder to explain, but there are also improved functionalities because the industry is learning, their networks are scaling, so they're also providing us feedback on how the basics of the protocol should improve. And I mentioned this also, the battery swapping. So with the great help from Korean companies and Indian companies, we've included that. Some new use cases, and here you see a snapshot of the specification, and very poetically we use all the different parts, use letters, and battery swapping has gotten the letter S for swapping. So quite a coincidence, but you see only a few use cases and a lot of mechanisms you can just reuse, but for the swapping action we needed to implement a few additional messages. So what's happening this year? Because there's already so much in OCPP, so are we finished? And of course, the industry is not finished yet, so we are also still working with the industry to move forward. And this is something exciting that I'd like to share with you, and that's about light. So OCPP is for all chargers, from Korea to California. You see small wall boxes for public chargers, for DC fast chargers. There's one OCPP that's for everybody. But of course, if you look at the bill of material of all the components that are in these different chargers, you can imagine that this very elaborate DC fast charger from Korea has a Linux system embedded which can fit anything. So if you code OCPP, it will fit. But if you look more to the smaller charging stations where you really have to focus on affordability, you make different choices in your hardware, and then happens quite a lot of time that these chargers don't have that much flash memory or RAM or ROM to incorporate traditional OCPP software stack. So one option is that, well, okay, these small chargers will stay on OCPP 1.6 forever. But then, of course, you always want to keep open the option for these affordable chargers to also at some point benefit from all the advancements that are being made in OCPP. So that's why we wanted to explore how can we develop a light version of OCPP 2.x. So first of all, it is true that OCPP 2.01 appears to be much more elaborate than OCPP 1.6. But if you look at it closely, to the left you see the OCPP 1.6 specification with the core part that you always need to implement, and then additional profiles that you can pick and choose. The same applies to OCPP 2.01. While it describes a lot of additional features, it also has a core part, and that core part you always have to implement. So even for 2.01, you can opt to only implement the core and leave out the rest if you don't need it. So for instance, if you don't have a display, you don't need the advanced user interface profile. But even a second aspect of OCPP 2.01 is that even within the core profile, a lot of functionality is optional. So if you really look at the basics of OCPP 2.01 and you only build the core functionality, you leave out all the options, that sort of leaves you with a similar size. So that what you need to build in 2.01 is of similar size in 1.6. So that doesn't mean that you can still use 1.6, but if you want to jump on the updated version, you can have a very slim implementation in 2.01 as well. So what have we done? We have set up a special task group, and we have tried to identify and quantify a light implementation of OCPP 2.01. Not just identify, but also quantify. So try and see how much RAM, ROM, flash is required to run OCPP 2.01, and see if that would fit on embedded systems. So what we've looked at is minimizing the firmware size, so only implement the essential messages that you would need for a lightweight implementation. Simplify the transaction handling. So in OCPP 2.01, you have a lot of options when to start a transaction, when you plug in, or when energy starts flowing, or when a driver swipes their card, or even when a driver drives up to the charging station. There are a lot of options to start and stop a transaction. And for the light implementation, we just have implemented one power path closed, and that fits all use cases, we think. Also, device model, which is a model of your charging station that you can read to see what the charging station supports. We've also looked at everything that we wouldn't need in a lightweight implementation, and also the random access memory. So we've tried to get rid of a lot of the additional stuff that have been included in OCPP over the years as optional features, but what you wouldn't need necessarily. So we've quantified, I mentioned this again, the CPU cycles, the RAM, ROM, flash memory. Also looked a little bit at the data communication, because there's also a cost factor. And we have concluded our findings in a white paper. And as with any white paper, you can find it on the OCA website, where the yellow arrow is, there is the white paper tab. If you click that, you come to all the white papers. And there we have uploaded the OCPP for resource-constrained devices is how it actually is technically called, or aka OCPP Lite. And what we are working on is 2 real-world benchmarks of a streamlined implementation of 201, which is described in this white paper. And it shows that it can operate within 50 kilobytes of RAM and 200 kilobytes of ROM. So that's really small, and that should fit on most embedded systems and the affordable hardware. So that's a great result. This white paper we continually update, because once we have the measurements from the open source benchmarks confirmed, because we do want to check it ourselves to make sure that what we publish is actually true. But we'll update the white paper with those figures. And if you want to start playing around with OCPP 2.Lite on your hardware, you could have a quick solution in just playing around with these open source stacks. And last thing I'd like to mention, so this is a topic that we've been working on, and we'd like to very soon organize an OCPP hackathon here in India, where basically what we'll do is we'll invite, so basically what we'll do is we'll invite anybody with a charging station who has resource constraint, and then invite them to try and get the OCPP 201 Lite stack implemented and tested, and get the feedback from the industry. So if you're operating charging stations with limited resources, does this work for you? We have a testing tool, and maybe some of you have seen it before, but it's a conformance testing tool that you can, with which you can test your charging station or your backend system. And you can test 1.6 or 201, it's the same tool. And we encourage you to have a look at it, because it really helps you. When you test, you see all the logging, you see all the message flows, and when it fails, it tells you where you are failing and why you are failing. And then you can click towards a test case to see, okay, this is the test case, why you are failing, and you can even click to the specification itself. So it is a test tool, but it's also a tool that helps you in debugging your own implementation. For certification is very important. So OCPP is free to use. You can just download it, use it. You're free to do so. We offer a certification program. It's not mandatory in any way, except for Korea. In Korea, it's mandatory if you want to get government funding. So if you want funding, the government wants you to show a certificate that you've actually implemented the standard in a correct way. And a few more slides on the certification program. So as I mentioned, we have a certification program for 1.6 and for 201. And the way it works, all the information is on the website, the procedure and how it works. It's very straightforward. And we have independent test labs that do the certification testing. So we have partnered up with DECRA and DNV, a sort of global organization, and particularly in Korea. We have specific Korean testing facilities. So we have KSGA, KTC, and KTL. The reason why we have so many test labs in Korea is, of course, because the government requires certification for funding. So there is a lot of activity regarding certification testing. What we are planning to open soon in Pune is a certification lab here in India. It will be very interesting to see how many Indian companies actually go for certification. Because, of course, when you certify, everything gets checked in quite detail. And we hope that a lot of Indian companies will make use of the opportunity to have a certificate in India itself. Hopefully that's something that would serve the Indian market. And we're also opening a certification lab in Japan. Japan, as you may know, is developing a lot of sustainable mobility, hydrogen, hybrids, but they're also, of course, working on purely electric vehicles. And for that purpose, there is quite an active industry in Japan, small but very active. So for them, we are also opening a certification lab in Japan to test for OCPP. By the way, all the labs are interchangeable, so if you certify at one lab, your certificate is valid globally. So they all perform the exact same tests. When you certify, the product that you've certified is published on the OCA website. That's important because sometimes companies claim that they are certified, and it's always good to check on the website if it's true. So if they have certified, they are on the website, and if they're not on the website, it could be that we've made an administrative error, so always check with us. But it's safe to say that if they're not on the website, they're not certified. So this is an example of a 201 certificate. This is for a DC fast charger by BTC. And what's also important to note that if you can download the certificate from the website, there's a lot of additional information, and particularly with 201, I mentioned previously, because there's so much optionality in 201, it's always good to check which options did this charging station implement and which didn't they implement, because 201 is not the same everywhere. So it's always good to check all the details. If you're purchasing a charger, check which options did they implement. And you can read it all from the certificate. What's also very important is all the certificates that are on the website are signed. And it's always good to check if the signature is still valid, because in the end it's a PDF. And it has happened that a company altered the PDF. So it's always good to check if the PDF signature is still on the document that you're receiving, and you can check it following the instructions on the website. To the left is very funny. Funny is so we were sent this certificate from a company from China, and it's a total fake. It has a fake number. It has a fake date. The certification tests have never taken place. So already we see the first fraud with OCPP certificates. And I think that's the reason is because sometimes it's mandatory to have a certificate, and then apparently there are some companies that just take a PDF editor. So some would say it's a sign of the maturity of the industry. People at DECRA, for instance, say, oh, we see this all the time, people's fake certificates all the time, but so now it's happening to us as well. So takeaway from this is always check the website and always check the PDF signature if you want to be sure that's a valid certificate. This certification program has been running now for 6 years, and we have received a lot of feedback from the industry, also a lot of complaints that it was too elaborate and it was too expensive, and so we've taken that all on board. So we've been working over the past year to improve the certification program, because of course we need to listen to our industry to help them. So I won't go into all the details, but we have a long list of improvements to the certification program that on one hand make it more efficient for parties to certify. So for instance, what we've introduced is a product family certificate. So if you have a series of chargers, maybe 5 different chargers that in the end all have the same OCPP software, but just different hardware, different configuration, what you can, as of this month now do is certify one, and then the lab will do a check on paper of all the other charging stations, and then all the charging stations will be listed on the certificate. So some vendors have a lot of different models, so that would make certifying that for them much more efficient and cheaper. So that's important. We've also added to the testing tool a vendor declaration of conformance, which basically means that a vendor does the exact same test as a lab, and that already is proof to a buyer that they have implemented OCPP correctly. It's not the same as having a neutral lab independently assess the conformity, but it's quite close. So for vendors who don't want to make the step towards certification, the vendor declaration of conformance is much better than no declaration at all, or just saying I'm compliant. And a lot of things to make sure that the certificate cannot be tampered with, because as I mentioned before, that's something that we're seeing arise in our industry. The certification program is developed also by our members. So if you're an OCM member, you can join a compliance working group, and you can make suggestions. But as I mentioned again, a lot of the complaints we were receiving over the past few years from the industry were not necessarily OCM members. So we also listen to parties who are not OCM member, of course. Then lastly, what are we working on in this year? So we have 2 working groups, a technology working group that's developing OCPP, and we have the compliance working group that's developing the test cases and the certification program. So from right to left, we have an OCTD user group. A lot of parties use OCTD, and they give us feedback on how the tool should improve or fit their needs better. And one example is you can now integrate it into your CI/CD, so your continuous integration, continuous development. And that's of course where we want to get at, where you yourself update your software quite frequently, maybe every day. And then every night you can run against the test tool to check if you haven't made any regression errors. So that's also something that we've implemented based on the feedback of the users, that they wanted to have a way to integrate the tool into the development cycle. And on the left you see the working group. So first of all, I mentioned the light working group. That's something for this year. We have a working group focusing on a local controller. The requirements for a local controller are not really well described in OCPP yet. So they want to make it more explicit and more clear, and that way more of a standard. The security task group, very importantly, what we are seeing in our industry is vendor vulnerability disclosures. Of those of you who know, if you encounter a device or something in the field that you think can be hacked, you can notify the authorities and you can say, I've discovered a vulnerability. Can you please help? And then these authorities, so you have one in the US, you have one in the Netherlands, I'm sure you have one in India as well. So what that authority then does, they contact everybody and they discuss the vulnerability and they help you resolve it. And this is what we see happening quite frequently, actually. Part of it, so, and we are included, of course, because they reflect on charging stations who implement OCPP. So many of the times the vulnerability that is disclosed has to do with the fact that the vendor didn't implement the security. So in OCPP we describe the security, but it's of course up to you if you implement it or not. So in that sense it's teaching us that the certification program is more and more becoming more and more important. So it's not enough to publish a standard with security embedded. It's not enough for vendors to say, I implement OCPP. It's really important to double check that they have implemented the protocol, of course, but did they implement the security measures? Because sometimes for some companies that's a bit left out of the development, and it's too crucial to not implement. And another example was where the vulnerability was in the charging station hardware itself. And that is not in scope of OCPP, but we are looking with our members to see is there anything we can additionally do also to help the industry adhere to the security requirements that are not necessarily for OCPP, but have a close relation with the charging station. So security is, I think, will only become more and more important, and that's why we have a separate task group discussing these topics. And lastly, commissioning. So particularly in the US, there are a lot of companies who are working on a business model where they offer a platform and allow customers, regular customers, just to buy a charging station out of Amazon or from Walmart and install it themselves. Of course, the electrical work will be done by an electrician, because that's too dangerous. But basically plugging in a charging station to a safe connection and commissioning it, that's something that they envision consumers doing themselves, like you set up your own Wi-Fi router, you can do that yourself. And at the moment, the way you commission an OCPP charging station is very complicated, so it's not standardized, so it varies from vendor to vendor. So this task group is focusing on a way, how can we devise a way that is very simple for end consumers to buy a charging station, plug it in, set it up to a backend, and have everything working for lay people. So that's something that this task group is working on. And of course, in the upcoming months and years, whenever someone wants to discuss a new topic, we'll of course pick it up. So that was my update for now, and if you have any questions, please feel free to ask, and maybe now or maybe later.
Thank you very much, madam, for the wonderful presentation, giving an overview of OCPP and also the pioneering work done right from the version 1.6, OCPP 1.6 to OCPP 2.1, and we really congratulate you for even OCPP 2.0.1 has been accepted as an IEC standard, and we wish you a brighter future in days to come. Indeed, we will take up the questions after the 2-3 more presentations.
Sure.
Thank you very much.
Okay, thank you.
May now request Dr. Anand Kumar Singh, General Manager, India Smart Grid Forum, to kindly make the presentation.
Thank you, Bala. Thank you, everyone. I can understand post lunch and after post one session. It is difficult, but let me do my part, and then I'll make sure that everybody is up and running. Next slide, thank you. So, Lonneke has given a wonderful overview of how OCPP is doing. And I'll be talking more about the Indian perspective and then how we can have the help of OCPP on board and all the good work that has been done. Recent updates, Lonneke mentioned IEC 63584 on October 20th, 2024. Why this is in bold and why I'm sounding happy is, I'll tell you a small story behind this. In India, ETD 51 is a committee that was formed by BIS to look after the all the development in the country for charging infrastructure, electric mobility in India. So ETD 51 had 6 panels, and one of the panel I was helping with that was responsible for the standards of the communication behind the scene. So we were given this task to write standards for the communication in electric mobility. We did it for 6 months. And then we reached out to Department of Science and Technology. The gentleman sitting on the dais, Mr. Suresh Babu, had also the chance to work with us then. And he was also instrumental in the development of all the charging standards. So after 6 months of good work, we reached out and we thought of that we have done our job. And then we realized that OCPP is looking a very promising standard. So why don't we go for OCPP rather than all the work we have done? That sounded logical also, and we looked into OCPP. We thought that yes, this is something better than what we have been looking for. So we thought of we'll go for OCPP. So then we, rushed to BIS, then OCPP's new standard, we can adopt this, but it was belonging to a private body. So in India, it is little difficult to adopt something that does not belong to government or government to government. So it was 2 years of running around this way, that way, we have to adopt OCPP. And this was the golden day when it was announced that OCPP is adopted by IEC, and then now BIS can adopt it. It's international standard, and life is easy now. We can have this standard as Indian standard, and then we can leverage all your hard work, what has been done at your end, this evolving this OCPP. I have never seen any standard that is so agile, so developing in last 10 years. And every next year you have something that as new and that has come. All those features was built, enhanced security features, improved transaction handling and smart charging. So this is going to help us big time in slides to come. I'll discuss that how it's not only a standard for us. This can be leveraged by many ways in India. Bi-directional charging and vehicle-to-grid integration is one of the big relief for us, because since last 1 year, ISGF is instrumental in developing or establishing V2G in India. So we are working just to establish, no doubt this is established technology, but in India this is happening first time. So, okay. So, we are working on it. I'll discuss that for how this is going to help us and how we can leverage each other's effort. Advanced diagnostic is, big time savior. When things are going wrong, then obviously you can learn from it, you can use it. Compatibility with ISO 15118 plug and charge is also a great functionality that can actually help us grow quickly. So these are the benefits why we are gathered here. So first thing first, interoperability is a big boon for us. Efficiency, optimized load management to prevent grid overloading in high demand urban areas. uh, in India, electric mobility is still new. Last couple of years now, after FAME 2, we have good number of electric buses in the market in India, in country. And then FAME 3, we were waiting, but now we have PME drive that has brought us a lot of new things in plate, where we can actually utilize that help from that has come from center to push electric mobility in this country. Scalability is also one big issue, and I think I'll say this is one of the biggest issue going ahead down the line. We have our experience in metering in last 10, 12 years. We have been talking about smart meters. We did lots of pilot across India, and then we recently the rolling out has picked up. I mean, the state I did pilot in 2012 is now rolling up smart meters in Gujarat. So generally it takes 10, 12 years when you talk about a standard, when you do pilot and then you actually execute it and things are on ground and you start leveraging the benefit of what you have done. We don't have to waste that much time, 10 years, 12 years, to reap the same benefit in case of electric mobility. Here, platforms are set, standards are good, and that can be adopted. And maybe we can say 5, 7 good years to reach up to a level where we spent 12 years in past. Remote monitoring and control, all this comes, and CPO would have efficient management of, once you can monitor it, then being a DESCOM, your life is easy. And everything that is done with the grid, either you are consuming energy or you are giving energy, providing energy, it's all DESCOM network. So eventually they become one of the key member here, and if you give them some control where they can manage it, life is really easy in that way. So this, I was just talking about this OCPP and then V2G. So how OCPP and V2G integration, or this entire effort that has been done, can be leveraged? It allows bidirectional communication between EV, then OCPP 2.0.1, what Lonneke mentioned, and later version supports advanced smart charging capability. So I'll talk little about how V2G is picking up. Since last 1 year, we are taking up this. We have taken up this project, and this is in advanced phase of closure. We have done almost everything that was needed. So we have retrofitted one of the Indian vehicle, Tata Nexon, with help of Tata Motors, and we had tied up with University of Delaware, and we leveraged their experience in V2G technology. They have been working since last 10, 15 years, and they help us to retrofit this entire thing. We imported bidirectional power module units, and then we imported bidirectional chargers. With help of UDEL, we retrofitted the entire stuff in one Tata Nexon vehicle. So there is the very nascent phase wherein we don't have any standard. In fact, it's like good old days when you connect your computer, put some commands, give some commands to your EVCC, and then you get a couple of bytes or something happens, whether the charging starts or discharging starts. So this is how it's been done. So now the question is, what next? Once we establish technology, we are writing model regulation around this V2G. So maybe next month, mid of month or end of next month, we shall be publishing the model regulation in India. So the next thing is how we are going to go ahead. It's like wonderful technology that can work as a savior of the grid, and that can actually, a couple of problems can be solved with V2G. I will discuss in slides to come. So that grid stability and renewable energy integration is one of the biggest challenge that is we are going to face. I'll name one example. One of the utility in Gujarat, they have almost done 5 lakhs of solar rooftops in the DISCOM. In Gujarat, it picked up like anything from beginning only. So now the peculiar problem what we are facing there, it's not we are going to face, we are facing there is during high peak generation hours, the inverter trips just because of the high voltage. So the rooftop that is boon has become a problem. And the irony is when your solar panels can generate maximum amount of energy, they are sitting idle because the inverter has tripped. Voltage is high and there is a range wherein they can operate. That's the standard range. And if the voltage is higher than that, the inverter goes off. So renewable integration has become, I can see as a challenge, it's not a challenge, but this can be worked upon. So the things we have started seeing, like how more of renewable integration is leading the grid into a direction, then now again the electric mobility is also picking up, 2-wheelers, 3-wheelers, 4-wheelers, cars, buses, lots of buses are also in the on the road from different schemes, thousands of buses on the road. So V2G, OCPP enabled V2G will be a big solution, or I can consider this as a wonderful solution to deal with the problems what we are going to face. The basic intent to do the V2G pilot is to understand where at the peak demand can we exhaust the energy that is saved in battery of the car or bus or anything, and during high solar or renewable generation hours, can we fetch that energy and store the same in the batteries of the vehicles. So that's the basic principle where we can actually enjoy high solar generation and maybe provide the cushion to the grid where we store when we have extra, and then we give back to the grid when there is high demand inside the grid, and then the DISCOM is going outside and buying that energy. So that time at a time of peak load, we can exhaust the energy and then solve this and help them flatten their load curve. Couple of more enabling smart tariffs. So while designing the model regulation, we studied all the tariffs that is actually as a proposed solution or is working outside India, Germany, Europe, many of countries. Netherlands also has a model. Japan, they have a tariff model. Australia, they sell very cheap solar energy during high solar hours. So we are also proposing time of usage tariff in India. We do have TOD, but TOU is going to solve the real problem once we have dynamic tariff, and then we can help users to understand that this is the peak and then there is the high demand, and then we need to exhaust, and then looking into the kind of storage that is there, and then how much depth of discharge is and how much actually you can exhaust. That can be decided on the real time. And similarly, the tariff would also play the same role in terms of bringing out the benefit to both the sides. This is going to be a little costly than your regular vehicles. So the extra cost where what I am putting in, I should have some incentive to go to V2G or go towards this, adopt this. Remote monitoring and control is also one big advantage here if we talk about OCPP. Necessarily, when you are discharging, your car needs to be connected to your charger, and this is going to be dynamic, or maybe in a way the timing could be different for different states or different utilities. So unless you have a smart charging in place wherein you go home, plug your car, and at the time of peak load your car starts exhausting energy from your battery or car's battery. So that is only possible when we have a smart charging in place. So thank you for having it in OCPP, and security and standardization is also one more concern that what we are going to see in future. And the way we go ahead and have scale it up, there is one challenge we are going to face. So these are couple of challenges, technical challenges, compatibility issue with legacy charging infrastructure. When we started, we did not envision that buses are also electric mobility, trucks are also electric mobility. In the beginning, we designed the entire infrastructure for two-wheelers, three-wheelers, and we didn't imagine that this is going to pick up like this. So then you will find all charging points 10 kilowatt, 15 kilowatt, 30 kilowatt max. Now things have changed. Now once you go along the road, you will find 80 kilowatts, 120 kilowatts, 240 kilowatts chargers all set up aside the roads in India. So similarly, we do have all legacy charging infrastructure, though it was not mandatory, and most of, I think, many of the Indian manufacturers would have OCPP 1.6 compliance, though it was not mandatory, but wisely they had adopted it then. Real-time data exchange for DESCOM coordination is also one challenge, though we have 250 million meters are being rolled out across the country. So that is a big leverage before having it here in the place. So once you start gathering data from smart meters, let it be consumer or mostly let it be DT, where you understand that what is the load and where you have surplus when the flow of current is reversed. So that will, which phase is balanced. Recently, I had visited one of the utility in Gujarat. There I realized that they had installed smart meters. Looking into their data, we realized that it's not only the billing thing, and it's not only the theft detection and AT&C loss reduction. It's many things. It's many things than what we can envision. What smartness can bring to your plate. Now we understand better that which phase is balanced, where we have to put new loads, how we can solve the problem. Earlier there was no mean, only there is some problem and something broke, you go and repair it. Regulations and market, there are solutions as well adopting smart metering, and AI is like new solution that everybody talks about. But yes, this is very helpful once we have data. So the basic foundation is being solved by rolling out of smart meters all across India. So now you would have data in place. And the big thing is, what do you do with that data? Whether you are running some models where you understand that what is going wrong. The basic things, your feeder fault management can be done. We'll be taking up one of the pilot for feeder fault management with artificial intelligence. How we can do it? So maybe we can take up one of the pilot and showcase this Indian utility that this is how you're going to solve your big problem with small efforts, technology in place. Standardization of OCPP with Indian EV charging infrastructure guidelines, though this is not mandatory, but people are wise enough. OCPP has been doing wonderful work. So certainly this entire continent can leverage this. All those manufacturer fraternity can leverage this OCPP. Regulatory and market barriers, lack of clear V2G policy, that is not there because this is very new. We have established technology in a way, we'll release it soon. We are working around the policies also. We'll be coming up with a model regulation. So there we can suggest, go to FOR and then suggest them this is how we can go ahead for adoption of V2G in India. Need for financial incentive and DESCOM, this will play a big role in the entire thing. So we have actually come out with a couple of suggestions in terms of tariff, going TOD or maybe customized TOD, what you can say time of usage tariff, and then the incentives what user can be given and the incentives what DESCOM can have from the entire thing. So in future of OCPP, integration of OCPP with a smart grid solution in DESCOMs, that is a wise choice to do it, because going ahead our DESCOM, or the grid is going to be very complex. Every next day you see the kind of solar generation we have, and one announcement from central government, and then you see crores of small solar rooftop plants joining to the grid. So they become a small generation unit, your complexity is not the same. Similarly, we have, and the electric mobility is also picking up. So we have lots of EVs also coming to the grid. So kind of behavioral change or kind of technology change that is required would decide that how far we go with what we have. So AI is one of the option where we can leverage this and solve with lesser effort we can solve bigger problems. Blockchain based transaction management, secure and transparent energy transfer. So blockchain is also one thing what can be integrated in the entire ecosystem. We have done another pilot where we established that EV charging can be done with renewable resource with help of blockchain technology, and there are renewable energy certificates also what can be sold in the international market or maybe in the carbon market. So there is a benefit behind this, that if you go solar or if you go green, you can leverage that thing. Impact on Indian EV charging industry, enhanced grid resilience. Obviously, once we have V2G and once we have OCPP, once we leverage OCPP's benefits or their functionality inside the grid, our resilience will be improved. Growth of decentralized renewable power EV charging infrastructure. So, it was matter of debate 5 years down the line when somebody is buying a car. So day one, you are energy, carbon positive. You have bought a EV. So almost 10,000, after driving 10,000 kilometers with green energy, you become equivalent to IC engine car. So it's a tacit responsibility of a EV owner that you go green. And if you are still charging your car with grey energy, then you have defeated the purpose. And the price of solar is going down. I think in time to come, we'll have cheaper solar energy than the grid energy. Policies are such that you can leverage it. Delhi has come up with a P2P energy trading policy that is very conducive. They have allowed 500% time of your contract load you can put solar capacity, and then you can trade with your peers. So and in a way they have waived off the wheeling charges also. So that policy is very conducive, and it can actually push electric mobility. Final thoughts: OCPP and V2G are critical enablers for India's EV ecosystem. Collaboration between government, DESCOM, private sector is crucial. So our job is to test the technology, write regulations around it, then go to the regulators and update them with the technology and what we have done, and then help them to adopt. We were able to do it with UP. They came up with a first P2P policy in India, or maybe I would say in the Asian continent. So everybody's help would be required. It's not only that what government is doing. From private sector also, I foresee private-public partnership would play a bigger role in time to come, adopt standards and solve the bigger problems. Thank you very much.
Thank you very much, Mr. Anand. You have given an excellent presentation highlighting the benefits of V2G integrated with OCPP, and also you have highlighted the challenges that has been addressed while doing the field trials, and yet many things that have to go a long way in addressing making it a commercial success in future. And without taking much time, I will move on to the next presentation. He's a Mr. Manoj Kumar Upadhyay. He's Deputy Advisor Energy, NITI Aayog. Sir, are you online? Are you there, sir?
Yes,
Yes, sir. We'll handle.
so it's actually को base करता है.
Yeah, over to you, sir.
कर लेता है और actually को हमने को base करता है. तो predetermined price कर लेता है.
Over to you, sir.
Okay.
Hello. Yeah, can you hear me?
Yes, sir. You can carry on. We can
Mr.
hear
Bala,
you.
can you hear me?
Yes, yes. We can hear you.
Okay. Thank you. Thank you. There is some issue on my side, so I joined some different link. I was hearing and there was some noise and there was a break. So I hope my previous speaker already spoken about the benefit and the other things. So I am not going to touch all those things, especially the case study that has been taught by previous speaker and the difficulty that they face for the digitalization of the infrastructure and other things. What I wanted to discuss here for vehicle to grid things, that government has already launched several schemes, and the prominent scheme which Ministry of Power is driving is basically a guideline for installation and operation of electric vehicle charging infrastructure 2024, which has basically commensurate all those requirements required for this open charging point protocols. Though there are a lot of other things to cover, because in other it is not covering the true nature of the open charging protocol, but yes, it is covering that essence of that one, and the other things that is promoting that infrastructure issues, like the FAME scheme, the PM E-Drive scheme, and the recently that the promotion of manufacturing of electric passenger cars, that is also contains some provision of that one. So if I cover in nutshell that whether India is working on this open charging protocol, yes, we are working on that one. We are on track, and the difficulty that was discussed by previous speaker about that, the preparedness of the distribution infrastructure and the standards and the basically awareness about these protocols. So on the distribution side, yes, there is a lot of challenge that the bidirectional grid, that is still not, I will say, not very much functional, though there are some bidirectional grid, but it is not connected to the many points. So a lot of pilots required to be completed to understand the bidirectional flow of the electrons, and obviously that the auditing, that the offsetting of those bidirectional flow of the electrons. And second point, that the compatibility of this flow of electron with the huge grid inertia. So we have a national grid, and that grid inertia required to have a balancing about the frequency and voltage, which require a coupler, or which require something called a boosting device to couple with this voltage and this thing. Though there is a different voltage level, but we are all connected with the national grid, and there is an issue for that one. So that is also require a separate discussion, which require a lot of infrastructure and lot of software and hardware combinations. So NITI Aayog, though working on the EV side and working on that charging infrastructure, especially that the swapping of the battery, which NITI Aayog prepared the guideline, and the ministry recently launched this guideline. But definitely this sector require a lot of attention, and basically the practice one, that we have to showcase some practice like initially NITI Aayog started this EV charging. So we have installed the free chargers in our campus, and still it is working on. So like this, we have to also install some free point where this vehicle to grid can be established and can be showcased. So we are ready to help the technology provider and the other companies, those who wanted to experiment and wanted to go and establish the business, and we are ready to support them and ready to hear them in NITI Aayog. So this is the limited intervention from my side. I'm ready to take any question on this policy things. Thank you very much.
Thank you very much, sir, for an excellent overview. Since you have to go, I'll give this time for question and answer session. Any questions from the audience you would like to ask Mr. Manoj? Sir, you would like to ask any question?
Yeah, just by way of policy, Mr. Manoj.
I hope I have finished my point. So did you hear me? I don't know, because there is no sign of any noise, any. Bala, can you confirm me?
Yeah, we can hear you well, Mr. Manoj. It's Ravi Seethapathy here, and I have one question with respect to the policy side. With respect to certification, which was emphasized by the previous speakers, is there any policy direction that, like Korea, you would also like to have an emphasis on certification for OCPP?
Mr. Manoj, are you able to hear us? Manoj sir, are you there?
I think yes. Okay, so what I'm going to do is I'm going to ask the question in a different way to Lonneke at the end as to what benefit did the Koreans get by emphasizing OCPP certification. So park that as a question later. Okay, Mr. Moderator. Yeah.
Since we are not able to contact him, we'll go for the next presentation, and after that we'll, if he's get connected, then we will ask the questions to him. So the last presentation for today is Mr. Nick Singh from ESKOM, South Africa. Sir, can you please take over?
Good afternoon, namaste to everybody. Thank you for this opportunity, Ravi and India Smart Grid Forum in India, to be part of this ISGW. My name is Nick Singh. I'm from the other part of the world in South Africa. I head up the Smart Grid Center of Excellence for the power utility called ESKOM. ESKOM is the largest utility in Africa. And we've been doing some exciting work in the space, and I just want to talk about what we've done to that. So ESKOM has started this journey quite some time back. We started off with those Nissan Leafs. So this is the Nissan Leaf era in 2013. We did some collaboration with Nissan Japan to try to unlock some vehicle-to-grid capabilities on these Leafs. I mean, the cars were absolutely terrible, to be honest with you. I mean, the range gave you more range anxiety than anything else. I drove a Leaf for about 6 months. And to be honest with you, we'll be lucky if you got 113 kilometers from that range, you know, without becoming anxious. But nevertheless, it was the first, and it was the start of this electric vehicle revolution. I am an EV driver, so I practice what I preach, and I walk the talk. I do believe that. I think in the previous conversations we were talking about, you know, green electric driver. I believe I am one. I charge off-grid. All my travels are done using renewable sources. So we're trying to be that change, as one of the great men from this country actually said, you know, be the change you want to see in the world. So I think if you look at this journey, it was a tough one. You know, I think being South Africa and being late adopters, we tried to understand having a grid infrastructure that was over, I mean, it's 101 years old now. And, you know, you got aging infrastructure, you got new technologies that are coming, and you had to do something radically different to be able to change the way we manage energy. We had a national electricity mobile program called EYELO. This was a very similar to OCP in terms of you know, a non-profit that was looking at advocacy around electric vehicles in the country. And we did that, so we did some vehicle-to-grid pre-feasibilities. I mean, it was only a 22 kilowatt-hour battery, so it was a tiny battery. We managed to get very little energy out of it. Obviously, there were constraints in it, but the overall lessons learned was that, you know, the varied discharge speed varied according to the state of charge of the battery in that case. There was very limited depth of discharge to 10% of state of charge. and then the sessions were interrupted and there were limitations to it. But nevertheless, it showed what was possible. There's some pictures of, where is this pointer? My eyes are, is it that? No, it doesn't point. You can see the pictures of very small, I think they were 2.5 kilowatt AC chargers. So I mean, we're talking about chargers, 250 kilowatts. This morning I saw some announcements of 1 megawatt chargers on cars. So I mean, BYD just announced a 1,000 kilowatt fast charger that does 5C on the batteries. So it's just getting crazier and crazier. Where all this energy is going to come from, guys? That's my question to you. You know, I was at Baku at COP, and we all are part of the Paris Accord. We're looking at carbon neutrality by 2050, yet we're still producing carbon. The carbon footprint, our carbon emissions have increased. I think it's in the 423 parts per million. It hasn't even leveled yet. We're still climbing, and yet we still have all these aspirations to have carbon neutrality by 2050. Something needs to drastically change. So all these electric vehicles, DER, everything we're doing in this space has to make this positive impact. Otherwise, you know, it's just going to be a whole lot of deliberations and strategies with no active implementation. And I think that's wrong, to have so many great minds around the table that can influence policy and legislation and not being able to do that successfully. Yeah, so let's look at the charger history. I think everybody's familiar with these pictures. You've got your AC chargers for home, you've got your DC chargers. That's now. There was lots of fights around which was the best, you know, in terms of CHAdeMO or whether you're going to use CCS. But I think, you know, that has leveled itself out. We have some outliers, but overall, we've adopted CCS as being the way forward. You can look at the aggressive amount of chargers in terms of the above 100 kilowatt range is now prominent now. That's going to be seeing, and that's going to be a larger part of our charge point operators in the future. Within South Africa, we've got just a few electric vehicle manufacturers. So you have the big guys there, Jaguar, BMW, Mercedes, Audi, you know, and there's a lot of other smaller Chinese companies that have penetrated the market as well. That's our charging infrastructure in the country. There's just over 400 public chargers, which is not much. I mean, I drive an electric car, and I can get around the country with it, but there aren't many electric cars in the country. So I think while the penetration level are still low, it's manageable, you know. If you look at the last number, you can see incrementally how it has increased. We had 154, then, okay, 2020 was COVID, so I don't think that applies. 2021, you know, 218, 502, 929, 130. So there's your curve, you know. So we're at the point right now where I think it's going to be exponential growth. And your network, and especially from a utility perspective, we need to be able to manage this. So what we've done is, as I said, we have edge infrastructure. We looked at containerized microgrids, which is modular microgrid solutions. It's power in a box. We managed to now utilize these systems as a option to charge electric cars. So you got lots of, it's a big country, and there's a limited amount of infrastructure around the country. So off-grid charging seems to be something that's attractive and that we've tried, and it's working. So, I mean, if you had to look at the fact that you got very old infrastructure and the amount of vehicles that are coming, how are you going to manage this? You know, if you're going to do capital upgrades in your network, it's going to cost billions and billions of dollars. So this was some of the research that we did. It was utilizing distributed energy resources and DC to DC charging to actually enable this, this capability. There's a lot more efficiencies in this process as well, in terms of lack of conversions from AC to DC and DC to AC and back again. And then obviously with DC to DC, your charging speeds are there. This is an example of what we've done. These are very, very small systems. They're only 32 kilowatt, 40 kilowatts peak, but in general, it can create 200 kilowatt hours of clean energy a day. That can power a single 180 kilowatt charger or 360 kilowatt charger. And if you look at the range, the batteries of the cars that's there, is generally between 45 kilowatt hours and 60 kilowatt hours per vehicle. And that can allow up to 4 full charges on that, or 3 on the latter, or half charges, doubling the amount. So you can actually get close to about 1,300 kilometers of EV range from one of these units a day, which doesn't seem like a lot. But if you look at the incremental deployments of electric vehicles, you don't have to go and put a whole lot of infrastructure out there and wait for the car numbers to pick up. You incrementally add more of this as it goes. You can add up to 2 megawatt hours of battery energy storage in these systems as well. So OCPP is an integral part to managing your grid and to actually getting that information up to a point where you can do control. Obviously the pros is that it's an open standard, and we all love open standards. Right? I'm a Linux guy as well. And it ensures interoperability between your stations, your network operators, and these are all positive things. I used the analogy with Ravi earlier on, where I said it's like if you understand DLSM COSM on smart metering, this is that for electric vehicle charging, except that you don't have a master-slave relationship. It's not very democratic. You've got a client. It's a slightly different way of doing things in terms of the architecture. The cons, however, I think there are. All systems are vulnerable to cyber attacks, as well as when you're looking at data and charging operations. It is complex, and I think you mentioned that applying it and getting it done correctly can become challenging. So if that's not done correctly, I think you can open up a weak link in your system, which will make it more vulnerable. The centralized architecture, in my opinion, can be a bottleneck. So I think as the numbers get bigger and bigger, that's going to be a challenge. And especially if you have diverse countries like with limited 3G or 2G or 4G, internet reliance can also be a concern for that. From a customer centricity perspective, it's most definitely a pro. With the fact that it will offer unified and efficient charging experience to our end customer. At the end of the day, we are here to serve our customers, our end users. So better grid management and optimization, managing your peak demands. We've managed to tie that into a FPGA, field programmable gate array, on the microgrid container. And we can now understand exactly the amount of energy that's just being dispatched to these vehicles. We did a little bit more research where we plugged in these proprietary OBD2 receivers on the vehicle side to actually understand what the car is doing as well. Right? So you can actually read that from the bus on the vehicle, and that spoke back into the FPGA. So you actually understood what happened to the energy that you actually dispatched to the vehicle as well. So that was something. So actually can look at the full supply chain. And I think, so this is just an example of, what we've done. That's all the control systems on the right-hand side with your field programmable gate arrays and all your protocols. And it becomes very challenging. We've got power stations across the country, and there isn't enough charge infrastructure. So we utilize the systems that we've now developed at Komati, which is a manufacturing hub for these units that the utility is now producing themselves. And it most definitely allows you to become a little bit more flexible in terms of where you want to use your fleet vehicles and how you can now utilize electric vehicles in this just energy transition that we all are undergoing. And that's my presentation. Thank you.
Thank you, sir. Thank you very much for an excellent presentation covering the work done by ESKOM in South Africa and way these interoperability concepts has been introduced. Now we will go for the round of discussions, panel discussion, and to begin with, sorry. We have almost an hour, 1.5 hours now. From now, we have to wind up by 5 o'clock, sir.
Yeah, we have an hour and 15
an hour and 15 minutes. Sir, with your permission, I would like to ask few questions, and then you can intervene, sir, wherever you feel is important. The first question I would like to ask Mr. Jay Prakash Singh. He was earlier in Ador company, Ador Energy. And sir, I would like to ask you, what are the key challenges being faced by EV industry in adopting interoperability concept in charging, especially in India? Because you worked in industry, you have seen all the ups and downs. I need your views.
Hello. So, yes, it's working now.
Yeah. Yeah.
So, key challenges regarding your question is regarding interoperability or what?
Yeah, adoption of the concept of interoperability in charging.
Okay, so interoperability is on the back end side.
Back end side, yes.
Okay, not with the vehicle.
Not with the vehicle.
So, actually, from the EV charger manufacturer side, there is no such challenge to adopt OCPP whether 1.6J or 2.4.1 or 2.1 because as Lonneke mentioned in the presentation, the hardware requirement is very less and we have enough memory and the processors in the EV charger which can control automation of the EV charger as well as the back-end network requirement compatibility, the hardware compatibility, plus the HMI section, the human machine interface like HMI, RFIDs and other inputs are required on the physically at the location at the charger end side and the vehicle side communication. So hardware wise, if we talk about the charger and the architecture of the DC fast charger or I can say for AC charger also is very much sufficient and capable to handle the OCPP and the cloud, whatever the information required by the cloud and the OCPP protocols and the authentication process and the security, safety. The hardware is capable to do it. And we are easily able to transmit those data with the Wi-Fi and with the help of 2G, 3G and 4G network also. Like in charger, most of the chargers are having 3G or 4G SIM capability as well as the Wi-Fi connectivity plus the data cable, Ethernet cable compatibility also. So chargers, almost all AC and DC chargers, not the personal charger, whether the people are using some personal charger for their parking lot, those are not internet connected. But I can say most of the chargers starting from 3 kilowatt to 250 or beyond high power chargers, all are internet connected chargers and compatible with the back-end network operations. Dynamic load sharing with the help of OCPP 2.1 we can easily do, power management we can do, and other features also can be implemented easily. But this thing, the certification part of those particular chargers with the OCA platform, right now it's is not there. The certification of EV charger with the that CPOs individually are done. Like suppose some EV charger manufacturers are working with the X CPO, then they are doing that integration one-to-one. And here the 100% I can say standardization is not there between the CPOs itself, because they want some unique feature in their network to attract the more customer. Like for example, some in 2.1 free charge and plug and go is there. But before this 2.1 OCPP, in 1.6J itself, some CPOs asked to implement or provide this feature plug and go, or you can say free charge. In fact, that was not mentioned in 1.6J, but some CPOs ask manufacturers to provide this feature. So the standardization, I can say, between the different CPOs itself is not there, because everyone wants some uniqueness in their system network so that they can attract more people, more customer on board with their network. Or maybe I can say this is because of competition between the CPOs. Standardization is not coming. And with the charger perspective and with the charger manufacturers, they are capable to integrate individually with different CPOs also. So if someone is asking some extra features over and above the list of what OCA is mentioning and OCPP 1.6, they are capable to do it. So from the point of the charger manufacturer, whether it's hardware side, compatibility with the backend network, and the requirement of the data handling or security, mapping of the some payment gateways, or I can say the management backend with the different satellite type of chargers are not there. So limitation with the charger manufacturers are not there. And the compatibility with the backend networks very much is flexible. They are able to deliver the product as per the market requirement. Okay, in line with the CPO's list of parameters. So the standardization, what I see is missing between the CPOs only, not from the charger manufacturer side.
Okay, sir, would you like to respond?
I think let the panelists.
Panel, yeah, okay.
It's not fair to.
Yeah, sure. Okay. Okay. Any response? Madam, would like to say anything, or shall I go for? Would you like to say any comment from your end?
No, I'm listening. So thank you for your insights, and I understand to some extent that as a CPO you would want to have special features within your own group, and I can only hope that at a certain point CPOs will realize that it's also easier just to follow a standard, and it will reduce their integration costs and will increase the number of vendors they can work with. But as long as they have a fixed set, then it's hard to argue with their reasoning. So I understand why they prefer to have a. It's not what we advocate. So we believe in having a uniform standard and be able to scale and grow and export. But I can respect if they have a different view as a CPO.
Yeah, thank you.
One point here is this standardization or certification. Will it applicable only for the EV charger manufacturer or CPOs also?
Oh, of course, both. So when I showed the slide of the testing tool and the certification program, it's both ways. So, and if you go to the website, you see a lot of CSMSs, back offices that are certified. And actually, it's easier to certify your back office than it is to certify your charging station. It's more work to implement OCPP and to certify a charging station than a back office. But of course, it works both ways.
Okay, thank you. The next question I would like to ask Mr. Bidyut Mazumdar. Before that, actually, I would like to share, I would like to request you to share your views on OCPP and then the work that we have been doing.
Good afternoon, everyone, and thank you, Suresh, for the question. So before I get into the topics, let me give an overview of what importance OCPP had in amalgamating this industry per se. Siemens as a technology innovator has been in e-mobility sector for more than 15 years now. And prior to 2009, it was mostly the home charging which was being popular. So a standard of what OCPP kind of brought in enabled business out of charging. Yeah, so that's how the business models of CPOs came into being. So the earlier versions were based on SOAP, and which kind of sowed the seeds of having the connectivity between the charger and the backend, which then after this OCPP 1.6 came in, really brought method to the madness, I would say, of increasing the public charging networks to a large extent. Coming to the Indian context, if you see right now where we are, there has been a huge growth in both the public charging networks as well as the commercial charging topics like the e-buses because of FAME and other government policies. Now, for all these use cases to be viable, there was a need to monetize the chargers, which meant that you have to have data from the charger going to some backend with which you can at least see what is the energy being consumed by each charger. And that's where the role of OCA has been phenomenal. That is one aspect I would like to mention to the forum. And second, now we are at a stage where we are seeing so many different implementations of OCPP 1.6 itself. And as Jayaprakash mentioned, each and every CPO who has taken the OCPP standards, downloaded it and built their own sort of CMS implementation, they have been adding more functionalities on the base what is there in the OCA guidelines. Now this has created different types of CPOs. The ones who are very much software or technology, I would say, good at that, they have built great systems which they are promoting across the country. And there is another set of startups, I would say, who are just implementing the basic OCPP guidelines and trying to push that as a new alternative in the market, which as a charger OEM, what is happening is that we are having to have multiple rounds of so-called OCPP integration tests, which each and every one of the CMS providers, which is both time-consuming for the ecosystem in general, and also to what end they are developing those new CMS implementations is to be seen. Because at the crux of the matter is that you have to have an efficient way to get data from the chargers to A, monetize the chargers, and B, to also make use of the security features which in the long run will be very important because chargers and electric vehicles are ultimately software endpoints, if you see that way, because they are IoT endpoints where you can, any potential, I would say, hacker can use that as injecting a maleficent code. So from that context, Lonneke, thank you for just letting us know what OCA has in line for standardization and certification topics, because this will definitely go a long way in harmonizing the entire back-end, I would say, the charging mechanism. For us, and I would agree with Mr. Jayaprakash Singh that for a charger OEM, it's just about equipping the controller with the firmware which can talk to an OCPP 2.1 or 2.0.1 backend. So from a hardware implementation, it's not a big challenge, but as you mentioned, one critical aspect would be for the CPOs or CMS providers also to be on the same page in the implementation method, the topic. Because what happened with OCPP 1.6 was, and as I also mentioned in our discussion, that the growth of the EV charging ecosystem in India has, as of today, been largely with the OCPP 1.6. So a shift to an OCPP 2.0.1 or a 2.1 will only be possible once the industry or the CMS and the charger ecosystem sees it as a benefit, because they have already invested so much in the cloud infrastructure to get that implementation done. And if there is a certification need coming from the top, that's what can be discussed by the policymakers. It will definitely go a long way in making that sure that the growth which will come henceforth will be on a common platform rather than having multiple implementations of some open source code.
One sectional committee, and what way we can take this open source protocol as a part of Indian standards, and what needs to be done so that it can qualify for adoption for it.
I think Anand mentioned that now that it's an IEC standard, it's one step easier to at least bring that to a discussion at the ETD forum to look at what standardizations can be done for the back end, because right now if you see, it is a democratic topic as of now, because even you and me can download the OCPP 1.6 stack, create our own CMS and start doing a CMS business, right? But for it to be a national standard, the specific prerequisites which are to be given, like what we did with IEC 61851, we took it, we adopted it for the Indian context, did some modifications necessary for the Indian ecosystem, and then made IS 17017. Now whether to have this particular thing as an annexure or appendage to the 17017 or have it as a different standard can be discussed at the ETD forum.
Hackathon that madam has mentioned, it will be very helpful, because when we do field trials using Indian systems and Indian users and all that, then we can get a lot of feedback which can be part of that OCPP Indian version, so that it can be accepted as a standard by BAS ETD committee, because that hackathon makes important, it's important step actually what you mentioned. Thank you. And next question is Mr. Akshay Mukesh from Ather Energy. In fact, they are two-wheeler manufacturers in India, electric two-wheeler manufacturers. Sir, the question is that what is the status of OCPP Lite and how this is going to help two and three-wheelers industry and challenges in implementation in India?
Sure. Thank you so much for the opportunity, sir. I think OCPP 2.Lite as a conversation itself was a pretext to what Lonneke mentioned. Back in the day when we first met Lonneke, and I think the conversation that we were having is very specific to what the two and three-wheeler industry was experiencing. Just the contrast, like if I have to give you the perspective of business and commercials and eventually charging infrastructure for two-wheelers being viable, the cost of charging a two-wheeler is usually 10% of what it would cost to charge a four-wheeler, considering the battery size and the pack size was very different. But what that also loosely translated to was that the cost of software or communication between both the type of vehicles was exactly the same. And we ran some math. If you look at data packet size, relay frequency, and storage of that data, over a period of time, the cost of communication itself was about 3.5 rupees per charge session. And that technically meant it was sort of contributing to 5% of the cost structure of a charging session of two-wheelers. So that's when we happened to have a chat with Lonneke, and the entire inception of OCPP 2.Lite came into play. One fantastic move that came from there is the modularization of the entire stack. So with the older versions, BR 2.0 or any of those, we were OCPP compliant if we adopted the stack end to end. Today, I believe we are going to be OCPP compliant if I am compliant with the module that is required for my business and my user base. So it's more about use case, picking the module and eventually implementing it in a way that works for my systems and not having to depend on the whole stack, still being OCPP compliant. So that was one of the major differences that eventually came out of there. Like I think Lonneke has already mentioned, and maybe we could reinforce that, the draft paper was presented sometime last year when we had the 2. Light talk here in Bangalore. And from there, I think we got a lot of feedback. The work's still been happening, and we're getting closer and closer to eventually publishing it as one of the white papers for 2. Light.
Very much. I think it has relevance for Indian industry, and it will benefit in many ways financially as well. And a lot of work has been done. Thanks for Lonneke madam for her effort. And now I'll come to Mr. Anand. He made a very good presentation, integration of V2G with the OCPP. And sir, actually OCPP 2.0.1 and OCPP 2.1 provides improved functionality in terms of additional support for bidirectional charging, distributed energy resources control, and smart charging and battery swapping. What is the way forward to adopt these new features in Indian EV charging industry? Indeed, you have, yes sir, over to you.
Thank you. Look, in the beginning, everybody worked with 1.6 OCPP. I mean, whether it was a mandate or not, but people were wise enough to at least adopt OCP 1.6. And it served the purpose in terms of standardization or maybe integration and multiple vendor who can come on one platform and leverage that. The way we are going ahead, 2.0.1 or maybe now 2.1, V2G I see something that came into play, and now smartness is, earlier it was an option, but I think going ahead this becomes a necessity of the ecosystem. If your chargers are not smart enough, you cannot talk to them, you cannot make them work the way you want to based on the information what you get from the grid side, then it will not serve the purpose, because you will not leverage that technology that has given you that much benefit, that you can charge, you can discharge. So now I think it is it is a mandatory kind of thing. It becomes a mandate that you should have it, and then once you have OCPP in place and once you are compliant, then it will lead you to work with your, I mean, India is a country where multi-vendor country. So we have been facing this problem since long in metering. I'll talk about 2005, 2010, 2011, we started doing a smart grid pilots. So that was the same challenge what we faced in the beginning of smart metering in India, that one DLMS compliant manufacturer or meter is not working with another DLMS compliant manufacturer. So it's the same problem that we can encounter now. So good that things are well in advance and they are available, so we can leverage that thing, that we whatever is available we can work with that, and that is excellent in terms of if you look at the ecosystem. And it's not one standard, it's like the policy also will have a bigger role to play here, and the way we can push it, and when V2G comes up, OCPP is there to facilitate it, then I think this will make sense, more sense.
Thank you. Thank you very much. Now we move on to the next question to Mr. Pradeep Aggarwal from BSES. Sir, in fact, we have done one project with you on LEV charge point. That was actually
LEVAC.
yeah, LEV AC charge point. In fact, we also felt that we need a back-end support to make that charger available in the public charging. Any views on that, sir? How OCPP can help in that AC charging?
I'll take 5 minutes to just bit of a background. As a EV market, we have two types of charging infra. One is private charging, where the vehicle OEM sells their charger. In India, it is 80 to 20 ratio. 80 is private charging, 20 is public charging. Public charging happens to be fast, intermittent, and as per requirement. However, private is come along with the vehicle, and it will be provided by the vehicle OEMs. And it is all generally of the low capacity. For two-wheelers and three-wheelers, it is ranging from 1 kilowatt to 3 kilowatt. And for four-wheelers, it is ranging from 3 kilowatt to 11 kilowatt. I'm sharing with you the on-ground experience from BRPL side. So what happens is, like out of the 80% private charging space, the two-wheeler and three-wheeler space dominates again. Out of 80%, again then 80% constitutes, 80 to 85% constitute two-wheeler and three-wheeler only. And for a smaller rating chargers, 1 to 3 kilowatt, the vehicle OEMs who are supplying chargers along with the vehicles, they tends to provide either a universal socket, number one. They tends to provide charger where just plug and play feature is there. There is no communication protocol. For four-wheeler side, the similar story again. And there are again maybe in the mindset of OEMs, like the chargers are not connected to the internet, there are data protection issues or some kind of privacy issues. So the 80% of the market constitutes the private charging space, predominantly slow chargers, not connected with the internet, not connected, just plug and play source. Again, coming back to the public charging, which is a fast charging and predominantly having a 20 to 25% space. These public charging happens to be a distributed or a hub charging. In hub charging, a charge point operator can make use of OCPP by optimizing the load requirement from a DISCOM. For example, if he has a connected load of 10 megawatt, but he optimizes his requirement, he chooses to opt for a 5 megawatt connection. By increasing the time of the charging and reducing the load. That's why the charge point operator can easily optimize the load requirement and their bill as well. But for distributed charging, we feel it's an intermittent charging and it's on-demand charging. The user opts to pay to charge fast their vehicle and getting compensated the DISCOM and get the DISCOM compensated. So the application of OCPP predominantly is in the space of public charging where chargers communicate with each other. There is a requirement of load management, optimizing the load. Now one pilot we did in 2019 with OCPP with a slow charger. What happens is whenever we reduces the load or we are opting for the smart charging and reduces the load of the charger, of course it's a 7 kilowatt charger, the charger trips. Because it is not, there is no functionality in the charger to work on a reduced V and I, voltage and current. So again, then we are told that these functionalities are being built onto. Now from a DISCOM perspective, when we start thinking of implementing or preparing a DPR for implementation of OCPP in the chargers which DISCOM owned, because for other charge point operators, we have no driving force or regulation in place where we ask them to onboard onto our platform. So we thought to onboard our chargers only. Then the challenge what we are facing is like we have other sources as well. For example, other DERs like solar. We have C&I consumers. So the primary aim of the distribution company is to manage the load and the DTs. DT is distribution transformer through which all resources are being hooked onto. So that time we then start again taking a forward step and integrating all the resources on a one platform. We are in touch with Open ADR. Then that time in 2020, 2021, we found that OpenADR and OCPP are itself is having a communication issues, which is now being resolved through new version, which I heard and got to know, ma'am. That is a very critical link, because as a DISCOM, what we are looking forward to is managing the entire demand of the DISCOM in a very optimized way. And the charging per se, managing the charging, smart charging business is up to the charge point operator and the algorithm which they placed onto their chargers. Like Mukesh ji said, for two-wheeler, the cost of inbuilding the motivational, there is no motivation to inbuild OCCP in the private chargers. Only public chargers will have a OCCP inbuilt into it. So I think from a DISCOM perspective, it's a good thing. We got to know many points. Public charging, it's a good. We have a standardized language where chargers, it can be universally adopted. OpenADR, through OpenADR, this can be again hooked on to, and OCPP and OpenADR communication can make sense also. We are also, as a DISCOM, looking forward to, for example, in a household, like I am talking about the private, again, consumer. We have out of 50 lakh, as a BSES, we have 50 lakh consumers. Out of them, 33, 34 are the residential consumers. Again, majority chunk. So for residential consumers, managing a demand with multiple sources, now consumer become prosumers. So again, we are also deploying the smart meters very soon, and we are into that tendering phase. So smart meter, through their apps, we can also looking forward to that, how can we manage the entire load of a premise rather than appliance-wise management. So as a DISCOM, we ask charging point operators that you must be communicated to us. But again, then there is a onboarding issues or problems which can be sorted out through implementation of ADR, Open ADR. Thank you. Yeah, coming back to the LEV AC point, sir. LEV AC, we have deployed, what happens is, sir, in the private charging program which we have launched in Delhi, we provided LEV AC chargers. It's a 3.3 kilowatt charger connected to a Bluetooth app. Now there is a very strong competition from the OEMs only, vehicle OEMs. 3.3 kilowatt charger is mostly being installed in the private space, and the vehicle OEMs are itself providing the chargers. So the limited numbers we could provided or installed in the society or the premises. It's 1800 across Delhi we have provided. And the response is that most of the developer charger OEMs who are manufacturing the LEV AC somehow hooked on to OEMs and providing them supply and not upgrading the versions of softwares. So there are connectivity issues as well. Again, then private charging owner will switch on to plug and play mode, that I don't want any connectivity to be in between. They just resort to plug and play. However, the LEV AC functionality which we have built through app provides a time of the day charging. They can plan their charging in the off-peak hours. Yes, sir. Yeah. But again, then the point Mukesh said that it will bring cost into the picture. So private owner will say, I will plug and charge. I will not publish this charging point to any outside source.
This question to Mr. NITI Singh, sir. How different are the challenges that you face in South Africa as far as utilities are concerned, and then integration of OCPP and other issues?
So, you know, we at that starting point, I believe, in terms of electric vehicle influx in the country and adoption. And as I said, we started off with those leafs that were 22 kilowatts, And then very quickly, you got vehicles that are now 90 and 120 kilowatt hours of battery storage. So it's changing. And then we're looking at long-haul transportation as well. So we started adopting electric buses, electric trucks. So these are getting even bigger and bigger. You know, so you're looking at over 1,000 kilowatts, 1.3 megawatts. It's going to be a problem. So these loads, these very dynamic loads, that's going to be either, you know, helping our grid or breaking our grid. Depends on which time of the day you're going to use it. It has to be managed properly.
Yeah.
So I think the protocols such as this is definitely there in terms of your integration up. So just like how we integrated our smart metering infrastructure into our head-end systems, exactly the same.
Yeah.
You know.
So do you have any system like what we have in India, that Bureau of Indian Standards approving a standard? Do we have that standards body?
Yes, so we, as South Africa, we got South African Bureau of Standards, SABS, and these are all IEC adopted standards. So we will take an IEC best practice standard,
similar to
same,
India.
exactly like India.
Yeah, okay.
So I sit on those standard boards as well, and we look at which ones are going to be applicable to our business, and we vote on it, and everything else just like everybody else.
Now this IEC has come, so IEC standard has come.
100%.
That can be adopted.
Yeah, so you have to adopt it.
Okay.
But I think, you know, even with OCP being open, the proprietary level that the charge point operators require, we need to draw a line, you know. Otherwise, you're going to start getting vendor lock-in again.
Yeah.
That part is going to start coming back.
Yeah.
And that's something we need to try to avoid as a utility.
Thank you, sir. Thank you. So one question to have, two questions from the audience. Yes, you can ask any question to any of the panel members.
Mr. Singh has shared few of the limitations during his presentation. My question is, Mr. Anand, when we are jotting down the regulations or standards. Okay. When we are jotting down the regulation for hello? Yeah. Yeah. So when we are jotting down the regulations or standard for the Ministry of can you complete my question? So while when we're listing down all of the regulations or standard or do and don'ts, these limitations, specifically two of them. One is the centralized architecture, which Mr. Singh you have mentioned, and second is the 2G and 3G spectrum, or basically communication limitation, and that's relevant for India also. In one of the remote location where you hardly find cellular network or RF network or whichever communication you want to use, do you see any challenge pertaining to that? That's my first question.
I mean, when we started, we used to have GPRS with us, 2012, 13, 14, when you try to download data from a meter, industrial, specifically industrial meter, and then from your MDAS, and it fails. Most of the time it fails. Then you'll make your junior engineer running to the meter, then he'll download all the data, he'll bring back to you. So that was the real challenge. Now moving to GPRS to 2G and 3G communication is little better. Now we are talking about 4G. We have 4G in fact running in our phones. 5G way ahead. And if Mr. Musk comes to India and satellite communication, and if it is at par cheaper with the available network, then that problem is taken care of. When in parallel to this, I mean, there's like technology is there. Technology is there. I'll give you one example. When I used to work with one of the power distribution utility in Gujarat, and then we didn't have that AMI-SP model. We had system integrator model, and then utility will raise RFP, and then they'll have system integrator will come as a lead bidder, then several other, I mean, it's a consortium. So necessarily somebody will be a communication service provider, somebody will provide meter, somebody will provide modem. And the SLA is 98%, 96%, very stringent. Once you start getting data, so you fail to get data on time, most of the time. And then you start chasing your consortium members that my data is not coming, my data is not coming. So if you are talking to a modem manufacturer, they'll say that modem is absolutely fine. It's working since last 8-10 years. And I don't see any problem in my modem. So you go to meter manufacturer, talk to them, my meter is working since last 40 years. There is no problem, it's absolutely fine. Then you go to the communication service provider, they'll say that communication is absolutely fine, everything is working. But at the end, my question was then why the hell data is not coming to my server? If everything is absolutely fine, then data should reach to my server. So I see communication as the weakest link in the entire ecosystem, but that has improved a lot. I mean, all those financial transactions are happening over 2G, 3G, 4G. So that is no more a very big problem what we cannot solve. We are not living into GPRS age. We have moved towards 4G. In terms of, from a DESCOM angle, if you want to collect data from a meter that is sitting inside a village, mostly a agriculture connection, where you sell electricity at the cost of 50 paisa or 1 rupees, and then you have to collect 500 rupees or 300 rupees a month, and you are spending 100 rupees to collect that data, then that will not make the business sense. So we have to take that call from the business angle also, that how much is being spent on how much. So
I understand problem is there,
yes,
but it does not have a lot of business value into it to solve that problem.
absolutely.
Because earlier when GPRS was there, the expectation of data was also low. Now, nowadays, when you're thinking and not even you're typing, the expectation is data should get loaded within no time.
Absolutely.
So if the communication technology is moving forward, so is the expectation of the user. Data has increased many folds, and a lot of analytics is needed. So not considering India is country of villages, and if you're considering mass of the population not covered during this whole analysis of this OCPP, I'm not sure if that could be a right decision.
This is always a question, that why to you're picking things around everything. Technology is not a problem. Technology is established. If I want to go to moon and I live in Nepal or Bhutan, then it's difficult. But if I'm in USA, maybe I can go to the moon. So technology is there, that's not the problem. Affordability of technology is a challenge, that whether I can afford it or not. Most of the Indian DESCOMs have been bleeding since long. Now I see good names. Gujarat is one name where all the DESCOMs are running in profit. Recently, Haryana has done that turnaround, then they are into profit. Then Tata took over to Odisha. Then, I'm pretty sure that they'll also come to look good into their spreadsheets. So technology has never been the problem, where you are spending. So that call you have to take. As a suggestion, what I can do, what Mukesh was suggesting, that the cost is, for collecting 5 rupees, you are spending 3 rupees as a information. So that will not make business sense. When we were going for LEV thing 4-5 years back, I had suggested that for the time being, you can actually give that pass to 2-wheelers or 3-wheelers. Because in terms of the kind of energy you are consuming and the mathematics you are putting on that energy is very less. So better we be more focused towards 4-wheeler 30 kWh, 40 kWh, and then buses, because they would make more sense. 256 kWh on board, trucks also, and then they will follow in. Once we reach to the scale of economics, then they will follow through. So maybe we can change our strategy. We can focus on the bigger thing where business sense is also served, and then later on, because they are not impacting the grid that much. I mean, 3.3 kilowatt is an additional load in my house, but 21 kilowatt is not, certainly not. You have to change the entire thing. So that is one way we can think of. Yes, please.
One follow-up question on that. So as we see, India is penetrating heavily on the quick commerce and the last mile logistics. And EV, especially two-wheelers, three-wheelers are playing very important role here. So as Mukesh mentioned, the cost of communication is higher. So how do we trap those data points, right? So when a lot of scheduling for those trips is happening, we need that data.
Right.
How the scheduling is happening. And two-wheeler, three-wheeler, I see the potential market currently.
Absolutely.
That is significant, right? How do we trap and how do we design the business model so that we generate the revenue?
Look, we learnt it from UPI. I mean, before Corona, hardly you see people using the online transactions. Hardly anybody would do, and if somebody is doing with great reluctance, otherwise it's all money that is playing role. Today, a thela wala or any chai wala would have that, or any rickshaw wala would have that Paytm or maybe that QR code, UPI QR code that is available. So we have learnt it in energy sector also. We are working on UEI, Unified Energy Interchange, backed by FIDE. They work for the rollout of the Ather card rollout in India. So we are working with that team, and we are working for UEI, wherein we can leverage, using the same technology, we can leverage those transactions where you can find out that where energy is available. And where is the buyer, where is the seller, that is all up in the market, and then on runtime you can do that transaction the way you buy or sell on Amazon. So similarly, you can buy energy or sell energy on over the web or through with the help of a mobile application. So that we are working on, and certainly I'm very much assured that this will serve the purpose. I mean, today, yes, it looks little challenging, but tomorrow it will be served.
Just like UPI, where we are transacting money, UPI will become transaction of energy.
Transaction of energy, and that will play a bigger role in V2G also, that I have 30 kWh in my or 15 kWh in my car, and that I can sell at maybe 9 rupees 50 paisa government is offering, but somebody is offering 12 rupees 15 rupees during night. I can just find out that I can sell it at 15 rupees, I will sell. So you will democratize the entire system that way, that I am free. I mean, I do have a cap with the network or with the utility service provider, but once you go to the market, that problem is solved. So it's all demand and supply. You have democratized it also. Yes.
One more, yes, Mukesh.
Also, I think something that we did, and any decision that we take at Ather is first user focused, but the next parameter that we look at is, does it make business sense? Okay. And the way we sort of solve this is to actually look at what does the user absolutely need and provide that first, instead of trying to provide. We understand and we always aim for the best experience, which is where the entire stack actually plays a role. But that's a business decision that most businesses should ask. Do I want, or am I ready, or am I in that financial position to deliver the most idealistic experience, or can I first stay true to my core service, which is charging, right? That requires two informations to be always sent out. Where is the geo location of the charger itself, and the availability. These two solve for absolute core requirements of what the user needs. Beyond that, a lot of things can just be done on the device itself, and anything above this. So Ather does provide plug-in charge as a facility, right, where you do not need to interact with the charger at all. But that's a business feature, and that's something that the business wants to provide as an experience to retain the customer. So then I spend on that. There's a certain value added to it, right? The value addition is that the customer now remains within my ecosystem. Correct. So what we try to do is reason out what you're putting out and why you're putting out, and what's the benefit that you're getting. It either needs to translate to immediate revenue from that transaction, or it needs to have some kind of an auxiliary benefit to it, which has some monetary value attached. So these are the two questions that we always ask before we define a certain experience to our users.
Thank you very much. Now we are almost coming to an end of this session. Now I'll request Lonneke madam. She heard all the views from the panelists, a lot of information, and India-specific challenges, India-specific needs, and OCPP definitely we need in India, and we will be happy to adopt that as a standard through BIS and all. And now we want to hear from you, taking all the views from the panelists and also from the audience. Any views from your end before I ask for the chairman to give his final remarks?
Sure, thank you. So on the one hand is a lot of the feedback I heard today is relevant for India, but on the other hand it's also not. It's relevant for everybody. So the questions you asked about the network connectivity, do I have a network connection? The question you asked, or the remarks you made about the discipline in implementing, and do people implement it precisely? Actually, those are all actually global. And coming back to the light, when I was here in India last year, we had a discussion about light and 201 being too heavy for two-wheeler chargers. A couple of weeks later, I was at Tesla in California, and they said the exact same thing. So the Tesla home chargers didn't have that much resources. So this is very surprising on the one hand, and on the other hand, it's not surprising that if Indian companies struggle with something, Tesla also struggles with it, because what everybody shares is, of course, great customer experience, but also affordability, keeping prices low. So, and sometimes at the Open Charge Alliance, we are already working on solutions, or we already have a solution, but also sometimes we need to be pointed out to certain needs and stuff, and that's why I value the cooperation with ISGF and with Ather and with many of you to provide us this feedback. Earlier in the presentation I said the criticism we got from Korea, but it's also really good, and also the remarks that you have made. All the remarks that you make we take on board, because in the end what we want to do is help the industry electrify. We think we believe in electrification of transportation. We are based out of the Netherlands. The Netherlands is really small, so if we sort things for the Netherlands, it doesn't make a big dent in the whole globe. So we really need to have a global transformation to electric mobility, and anything that we can do to help, we will do. And yeah, just keep the comments coming and keep the criticism coming. Don't hold back. Because we'll listen, and we'll do our best to fix all the issues that are still there.
Thank you very much, ma'am.
No, so OCPP is really focused on the communication between the charging station and the CPO network. And you are so right, there is of course also a lot of communication from the vehicle to the OEM cloud, and that is also a very efficient route, I think, for communicating anything to the vehicle. You can use communication to the charging station, but you can also communicate through directly to the vehicle. So that is in many OEMs are also focusing on that. And I think if it helps electrifying and increasing the customer experience, that's great. I already mentioned Tesla. Tesla does it a lot, they communicate a lot through the vehicle. So that's great. For OCPP, we're sticking to our scope. So it's for charging station to back-end system. So I don't expect automotive industry to start using OCPP for telematics. If they want to, they are more than welcome. So they can use it because it's open source. But so far, apart from your idea, I haven't encountered it personally yet with any OEM. But if they want to, they can.
Thank you very much, ma'am. Now I request the chairman, sir, to give the final remarks. Sir, over to you, sir.
There's just one question. I wanted to ask Dr. Manoj, which I could not, so I'm going to ask you. What do the Koreans actually benefit by insisting on certification?
Yeah, so just for clarity, in Korea, if you want to get access to government funding for charging infrastructure in Korea, you have to certify for OCPP, not just be OCPP compliant or OCPP conform. You actually have to show a certificate from one of the 3 Korean test labs. And the first reason, the first benefit is for the Korean government, because they are handing out a lot of money. So it's millions and millions of dollars to use that currency. And of course, if you spend that amount of money, you want to have some guarantee that you're actually getting what you're paying for. So in the first benefit is that the Korean government gets proof of compliance from an independent institution. But there's also a second benefit, which I think is even greater and which is possibly, and I can't speak for the Korean government, but what is possibly their ultimate motive, is that with handing out these subsidies and asking for certification, it has resulted in more than 80 companies certifying. So there is a huge number of Korean companies who are OCPP certified. And of course, Korea is not a big country, it's only 30 million inhabitants. So you can wonder, can one country accommodate 80 different companies? Is too much for one market. The thought behind this is export. Korea is a front runner. They are one of the first to electrify. And since OCPP is used globally, it enables Korean companies to learn and to build up their systems and their technology inside Korea with the support of the Korean government, and then export to California, for instance, where certification is also mandated, or to Europe or to other regions in the world. So I think from the Korean government is really clever. So they benefit from the standard to build up a big industry in Korea, to have a lot of competition and a lot of innovation inside Korea, which will benefit their own country. But secondly, also position their industry for exports. So I think that also could be an idea for the Indian government. If you really not only recommend a standard, but you require a standard, and you also require like the quality checks of implementation, it could not only benefit your own ecosystem, but it could also position you to export to other regions by the time they start adopting e-mobility.
So something for you to consider in your policy is to where you want to bring the hammer down and where you don't need to. And I think there may be a validity if some of these folks here become exporters, right? And then therefore you get that better leverage as an export market. So thank you, Mr. Moderator. I just want to close. I think we had a very interesting discussion, but I think as an ex-regulatory utility person myself, you're going to see this dichotomy of what drives business and what is done to control loads. I think you can't get away from it. There is no way you can get away from it. So there is a mandate for these two folks here to control loads. There is a mandate for you folks to actually generate business, right? And so I don't think you can get away. The equivalent that we bring about when in Canada, for example, is when you have a load that is way below your maximum demand, or even 50%, lower than 50% of maximum demand, you have the right to have dumb appliances. You don't need smart appliances. So the customer has a choice to have a fridge which doesn't do anything. You just plug or an iron or whatever, right? Wherever we then ask for connectivity, for example, my water meter is connected, my gas meter is connected, my electricity meter is anyway connected. That that connectivity is given to me because there is a benefit that somebody else derives. And for that then, I go through my Wi-Fi. So I don't ask a separate GPRS chip on a meter so that it goes directly adding 3 rupees or 5 rupees or 10 rupees. For us, by the way, it is 30, 40 rupees on a chip. Our SIM cards is the most expensive thing in Western countries. So we tend to go that way. So by allowing them to go through the Wi-Fi, not of course using the bandwidth of the home and not being able to do anything, but allowing for say a set of data to be transported, there is a benefit that's given to the consumer for having connected to it their Wi-Fi, right? And so that is something to be thought of as to what the utility would like and what the OEMs would like. But having said that, there are 3 or 4 things that I sort of notice, and maybe I'm not saying it's alarm bells, but it's something to be thought of. The notion of in the electric world, especially as a utility, the moment connectivity goes, whether it's controls or protection, it falls back to a fail-safe, independent level of control. So the charger must be able to say, okay, I'm an OCPP vendor, a large vendor, medium vendor, whatever. I should be able to say, if for whatever reason the connectivity goes, it must fall back to, let's say, a 20% charge or a 30 or a 40%, 50%. I didn't hear that. Maybe it is, but I didn't hear that. Because that would be very dangerous if all of a sudden the connectivity goes and then your charger is operating at 90%, right? Not knowing where it's going. The second thing was DC to DC, I think that Nick mentioned. The question on DC to DC, I think, is the right way to go going in the future, simply because we don't have the infrastructure to keep on adding chargers. I can tell you this, no country, no utility will be very welcoming of the proliferation of chargers onto the AC network, because the AC network was built like 40, 50, 60 years ago. And so you're not going to get that. So the question is, the DC to DC concept that he mentioned is, how do you bring that to the city? Now, there is another way that we bring, and Israel brought it up. In fact, Chakratech, I don't know if it's called something else now, but Ilan Ben David, a good colleague of mine, he has rotating machines in the corner of streets which can actually charge electric vehicles. So what you do is you're using the rotary momentum of various, call it armatures, if you will, to charge, as opposed to just solar. So you can augment solar with this, but the key is to get off the grid. Because the more you get off the grid, now you can talk energy and not demand. And that is the question these two folks also were contesting. Is every time we connect something, we are talking of actually demand. We are not talking energy. Energy is what you meter, but these two folks are worried about demand, right? And so the more you come off the AC grid, like Nick mentioned, I think the better are your chances for your businesses to flourish. And so we need to think that through as well. The third thing that bothered me a bit was with respect to backward incompatibility, RAM not being available, or things like that. And I'm just trying to compare it to the CPU, the PC market. If there is a way to standardize and say, okay, a spare RAM slot should be given. So that later on you can actually go and put a RAM, okay? Or a spare SIM storage should be provided so that you can insert a 1 gigabyte disk or whatever. I think may go in longer ways so that they are not incapacitated with backward compatibility being an issue with the OEM equipment. Because right now you can almost strand half the OEM equipment today in India because it doesn't have the RAM and it doesn't have storage for forward compatibility, which I thought was a big issue. With respect to CPUs, and if I understood correctly, again there's a parallel in the PC market. I don't think you should start controlling CPUs. The CPU is an advantage or a disadvantage that the OEM decides, just like I decide an Intel inside, a Ryzen inside, or any of the chip inside. What they provide is benefits on the software side such that you buy their equipment and you can then market yourself to differentiate with respect to somebody else. So I don't think to go back, you don't need to be a communist state, let's put it that way, to say everything has got to be done with that way. So we need to think that through as to how far and how deep we will go with respect to even going down to that level. The last is, I think, in the concept of where will we draw the line on business side is a bigger question. The utility would like to say, okay, I need to see, this happened by the way when we had renewable power back in 2004. How many data points do I want to see behind the meter was a question we asked in the utility. When somebody puts a solar panel or puts a large wind turbine for a farm, how many data points would we want to see? And then we took a line and said, we don't need to see these guys, we only need to see those guys. So it could be that the two-wheelers, three-wheelers will fall off the radar, and the bigger ones will be visible for purpose of control, if you will. There is also a second method that we employ, and I don't say you have to do it, is to use non-certified meters because the cost is cheap. So if you put your ring, you know, what you call the open, there's a word for it, anyway, a clamp-on type of device on the circuit, or a line circuit that goes to your charger, you can actually get the energy, except that it's not certified. But it costs 1/10 the cost. Now, if we employ that, in fact, in subdivisions of residential towers, to allocate certain charging costs, etc., amongst various points. But that is an internal discussion we have, as opposed to going to a metrology test or going towards a standard and saying, that's the way we want to allocate. So as human beings, I'm just trying to come back, we have always lived with certain non-policing standards, if you will, to drive a business case. So in case of selling outside of the network without wheeling charges, you may want to say, okay, what is the method by which I'm willing to live with a certain amount of inaccuracy, or have another mechanism for accuracy to be built in, as opposed to going through metrology test, and every 8 years smart meter has to be pulled out, a particular sample has to be calibrated. You're throwing a big money at a very, very small problem, and therefore you kill the business. You actually kill the business. So the question in this peer-to-peer trading and home residential network, etc., it may be okay that it has got a 1% inaccuracy, big deal. But at least have somewhere where your business can grow. And so that goes back to our old days of barter, if you will, where a cup of sugars used to be given between homes. Who cared if you were 1 spoon high or 1 spoon low? But something like that. I'm not saying you should go that way. So the point, I think, is electric vehicles is moving east. Okay, I'm coming to that. From the west is actually physically moving east in terms of numbers, because the weather patterns also to some extent favor it. You're not in very, very cold climates. He talks of Nissan Leaf at 100. My Nissan Leaf only gave me 40 in the cold. Okay. Not only that, the Nissan Leaf burnt all the appliances at home, including the fridge of a supervisor, and I had to replace everything. So we have that issue. But the key question is moving east. China already is dominant. Japan is dominant. Korea is dominant. The question for you, Mr. Moderator, is, does India want to be dominant? If you don't want to be dominant, we can keep discussing this. If you want to be dominant, you've got to sort of solve what we discussed today. And I think it was excellent on your part to have moderated and got the question. But you also being in DST now, you're saddled with a lot of these things going forward. So it's not a great ending for me. But thank you, Mr. Moderator. Thank you very much. Thank you all.
Thank you, sir, for the excellent concluding remarks. Thank you, the panelists, for your wonderful contributions, and also participants for your questions and also for your participation. Over to Mr. Bala.
Thank you all speakers for sharing your insightful thoughts and valuable contributions on V2G and OCPP standards. Now I would request all speakers to come forward for group photo.